Hey guys! Alright, today we're doing Chapter 8, Section 6, which is on combinations. So, a combination is really similar to a permutation, which we learned about in Chapter 7 when we were talking about probability. So let's talk about permutations again. A permutation is an arrangement of objects n in which order is important. So remember, one of the ways that we use permutations was we talked about horse races, and we said how many different ways can I get the finishing lineup of a 7-horse race. Okay, and that was going to be 7 factorial, because if I had my 7 dashes, in my first dash I would have 7 horses to choose from, then I would only have 6 horses to choose from, then I would only have 5 horses to choose from, so that would give me 7 factorial ways that I could place that horse race. Okay, so a combination is essentially the same thing. The only difference is that in a combination, order doesn't matter. Okay, so really important. In a permutation, order matters, and in a combination, order doesn't matter. Okay, so in this section, probably the hardest part is that you're going to have to pick between whether or not something is a combination or if it's a permutation. So you have to really think about, does order matter in this problem? Okay, if it does, if order matters, that means it's a permutation. If order doesn't matter, that means it's going to be a combination. Okay, so the first problem is the handshake problem, and if you look at page 523 in your book, it kind of walks through an example of what this handshake problem actually means. So it says, if every student in the room shakes hands with every other student in the room, how many handshakes would we have? Well, normally this is where we would go around and shake everyone's hands, but this is a video, so we can't do that. Okay, but we can think about what would happen. So, if you look at page 523 in your book, notice that they listed out 6 friends, and they said J would shake hands with K, L, M, N, and O, K would shake hands with L, M, N, and O, L would shake hands with M, N, and O. Okay, so what you'll notice is that we've got 5 plus 4 plus 3 plus 2 plus 1, which is 15. So that is like n factorial, except I'm adding all of my terms together more like a series. Okay, so I'll let you guys go ahead and do the handshake problem depending on how many students we have. Okay. So next up, we've got this definition here. So NCR, that's n choose R, that's the number of combinations of n objects we can take R at a time. So just like a permutation, we had NPR. Okay, I was saying that I can take R objects from a pool of n objects, except with a permutation order matters, and with a combination it doesn't. So this is the actual formula. N choose R is going to be n factorial over n minus R factorial times R factorial. So this is really similar to a permutation. Remember, the formula for a permutation was n factorial over n minus R factorial. So the only difference is that now I'm dividing by R factorial as well, because I'm saying that order doesn't matter, so all those different variations of R that I have are no longer important, so I can just divide them out. Okay, so let's do some problems. 20 students are semifinalists for 3 scholarships. One scholarship is $1,500, one is $1,000, one's $500. In how many ways can the scholarships be awarded? So the first thing I need to think about is, does order matter? Well, put yourself in the place of one of these students. Does it matter which scholarship you get? I hope that you would say that the answer is yes, order matters, because I would much rather get the $1,500 scholarship than I would the $500 scholarships. So that means that since order matters, this is going to be a permutation. So I can say I'm choosing I'm permuting 3 from a pool of 20, so that's 20 permute 3. And if you plug that into your calculator, I'll just write it as the formula just so you guys can get familiar with the formulas again. That's 20 minus 3 factorial on the bottom. So this is 20 factorial over 17 factorial, which remember, that's just 20 times 19 times 18 And once you get down to 17, they'll both cancel out. Alright, so I've got 20 times 19 times 18. When I put that into my calculator, I get a total of 6,840 ways that student, or those 3 students, could be awarded these finalist scholarships. Okay, so the next problem, I've got 20 students are semifinalists for 3 scholarships. All are worth $1,000. In how many different ways can they be awarded? So in this one, I need to think about, does order matter? So each of these scholarships is worth $1,000. Does it matter which scholarship I get? The answer is no. Okay, so order does not matter in this problem, which means you can use a combination. So this one is going to be 20 choose 3. So remember, if you write that as your formula, you have 20 factorial over 20 minus 3 factorial times 3 factorial. Okay, so that's going to be 20 factorial over 17 factorial times 3 factorial, which, if I simplify that down, I have 20 times 19 times 18, okay, and then I have this 3 factorial, which is 3 times 2. So essentially what I'm doing is I'm taking this number here, and I'm just dividing by 6, okay, and when I do that, I get 1,140. Okay, next one. A Mexican restaurant contains 24 main dishes. A group of friends chooses 4 different dishes. In how many ways can this be done? So, again, the first thing I need to think about is, does order matter? So I'm choosing 4 dishes, and does it matter what order this waiter brings it back to the table? Well, not really. So if someone messes up a dish, if he brings it back and gives it to the wrong person, they can just move it over and give it to who it belongs to. So does order matter? Not really. We're going to use a combination for this one. So I've got 24 dishes. I'm choosing 4. So it's going to be 24 choose 4. So it's 24 factorial over 24 minus 4 factorial times 4 factorial. So that's 24 factorial over 20 factorial times 4 factorial, which is just 24 times 23 times 22 times 21 over 4 times 3 times 2 times 1. Okay, if I plug that into my calculator, I get 10,626. Now remember that there is a button on your calculator that does this for you. The only reason I'm writing it all out like this is because, just like we had with permutations, there's going to be problems that involve variables, and I want to make sure that you understand how you can simplify it with variables in the problems. Okay, so we can also use combinations in order to figure out probabilities. So remember that with probability, we talk about the number of outcomes of an event divided by the total number of possible outcomes. We can do the same thing for combinations. We just say the number of ways to choose an event is in the numerator, and the number of possible outcomes is in the denominator. Okay, this is kind of a tricky problem, so if you need to rewatch it, feel free. But basically, if I have a football team of 95 players, and I'm randomly selecting 10 players for drug testing, I want to find the probability that the starting quarterback and the starting middle linebacker are both selected for that drug testing. Okay, and again, we're assuming that this is a random selection. So if I want to think about the number of total possible outcomes, well, I am randomly choosing 10 people from a group of 95. Does it matter what order they're drug tested in? Not really. It's going to be the same group of people. Okay, if you're drug tested first, good for you. You're all just standing in a line. You're getting drug tested the same day. Doesn't matter. Okay, so order doesn't matter in this problem, which means I'm going to use a combination. So if I want to find the total possible outcomes, I'm going to do 95 choose 10. So I'm choosing 10 people out of the total of 95. So that's my number of possible outcomes. Okay, now if I want to think about the actual number of ways to choose an event, So in this case, I have to choose the starting quarterback and I have to choose the starting middle linebacker. Well, basically, out of this group of starting quarterbacks, there's only one starting quarterback, and there's only one starting middle linebacker. So out of this group of two people, I'm choosing both of those people. So that means that I would have to choose two. Okay? Then I have 8 other people to choose. So I've got 8 more people to choose out of a total of 93 people left on the team. So 93 choose 8 is going to be the other part there. So the number of ways I can choose that event is going to be 2 choose 2 times 98 choose 3. And this 2 choose 2, you'll notice, is just 1. So it doesn't really matter that it's there anymore. Okay, so now if I want to simplify this probability, I've got this divided by this. I'm going to write them out and simplify them as if there were variables, again, because I'm trying to make you guys understand how to do it if you do run into variables. So this 93 choose 8, that's just going to be 93 factorial over 93 minus 8 factorial times 8 factorial. That whole thing is divided by my 95 choose 10, so that's 95 factorial over 95 minus 10 factorial, 10 factorial. Okay? So if I simplify this stuff, this is going to be 93 factorial over 93 minus 8 gives me 85, and 8. And notice that if I'm dividing, that's the same thing as multiplying by the reciprocal, so I'm just going to write it that way. So this is still 95 factorial. This one simplifies down to 85 factorial, 10 factorial. Okay, well these 85 factorials here are going to cancel out. 93 factorial over 95 factorial, well if I think about that, this is the same as like just 95 times 94, and then everything else will cancel. Okay, same here with the 10 factorial and the 8 factorial. This would just be like 10 times 9, and everything else will cancel. So essentially, this is just 10 times 9 over 95 times 94, which gives you 90 over 8930. So that's the probability that out of 95 people on your football team, the starting quarterback and starting middle linebacker are both going to be selected for random drug testing. And that's everything for Section 6.